I'm Tanmay. I'm going to spend some time on this slide because it's the prettiest one. Everything else is done by an engineer. So, so I'm Tanmay. I work for Adobe. I'm a site reliability engineer. I've also been called a DevOps engineer in the past, depends on the organization. So, I do a lot of ops work. I also do some programming as well. So, but my primary focus is more ops than dev. So, what I say here is from the heart because I have to wake up at night. So basically, those that kind of thing. So, last few years. I don't know if you can see that code properly, but if you can't, I'll read it out. But anyway, so this talk is all about writing good Dockerfiles. Now, as I was just mentioned, the container has become synonymous. It's everywhere. So there are things that containers do very well. This has led to a rise in a lot of containers everywhere. So advent of microservices containers land very well. Like it's not the only way, but just one of the very nice ways to do that. There are a lot of cluster orchestrators now which orchestrate containers, and I think this has become also, again, was mentioned Kubernetes, I think. So all these kind of things, they are working on containers, and that's why they become so popular. CI/CD, all this kind. I'm not saying this is the only way you can use containers, or the containers are the only way to do this, but this has led to a reason why they've become so popular now. So, I also started working with containers and Docker specifically. I also work with others, but Docker, I'm not talking about Docker here specifically. And I wrote a Dockerfile very similar to this one about 3.5 years ago. I was very proud of it. This is a simple hello world application written in Flask. And all I've done is install, so to run Flask I need Python, I need the requirements, and I just need to run it. Right? This is all I've done. And it looks very simple, it looks very neat. Much worse Dockerfiles are run in production. So if you have done this kind of thing, it's not a problem because everybody starts like this. And then like this. This is literally me when the boundary between ops and dev used to be a lot bigger. What happened was the server goes down. Why? Because the server we were running on is out of space. Come on, it's a hello world application. And yes, this is an exaggeration. Hello world won't probably do this, but we run real services in production, and this does happen. So Docker system prune, this is also something new. Wasn't there when we started, so I have to manually go through images and delete them. This is the kind of thing I was doing at 3 in the night. And just decided, okay, this is not good. You can see other things also which are in there. Dockerfile which is not written properly can take a lot of time to build, and this is the problem. So developers will, you've heard a lot of organizations goals that we do 500 deploys every day or 600 deploys every day. If you write Dockerfiles like that, that's going to be very hard. And last point I want to make is about security. So the problem with this Dockerfile is it has a lot of stuff that I don't need. And if there's stuff that I don't need, there's a high probability that stuff is vulnerable also because I don't care about it. I never care about upgrading. So this kind of thing also leads to a very large security vulnerability. And it's not something the developer cares about. And these are the problems over here. So this was a hello world application written in Flask. If I had used that Dockerfile, I would have had an image of 469 megabytes for hello world. That sounds wrong. It should not happen. But when you're on your system, you're developing, you're writing a Dockerfile, and it works. It prints out hello world, which responds to your request. You're happy enough. That's how we start, and that's how I started as well. And it was good for a while until that happened. And again, it takes a lot of time to build because I have to go through the entire dependency thing and I have to install all the dependency. If I change hello world to hi world, I have to wait for a build again. And that's not good. Again, the point I was making, I want to deploy 500 times a day. That's not going to work if I have such a slow system. So all of this can be avoided, and this is the kind of thing which we are going to talk about over here. I'm going to divide this talk into 2 parts. So one is to reduce the base size of the image, or rather not the base size, the actual absolute size of the image, and the time it takes to build it. That's the part 1, and that's what I'll be focusing on in the next slide. But later on, and I think more importantly, the incremental builds. So changing hello world to hi world, that should be instant, right? It's just changing one word, just changing one file. That should be quick. That should not add a big delta to my file. So it's okay if I have a 500 MB file in the beginning, but if I'm changing something, should not create a 500 MB in the beginning because I change just one layer. So talking about layers, and I'm going to talk about layers quite a bit over here. So this is not so clear, but this is kind of explaining you. This is an image I pulled off the docs from Docker, and this kind of shows you this two layers, rather two compartments here. The first one, this one, the solid ones are the image layers, and the one on top of is the container layer. So this talk is going to focus on these. I'm not going to talk about the container layer because I'm talking about writing Dockerfile, and Dockerfiles in the end produce this. They don't worry about the container. Just so we're clear, I'll still make it obvious what I'm trying to do here. So you always start a Dockerfile from a prompt statement, which means your base, the place which you're starting from. It can be Ubuntu, can be something specialized. I think you all must know, have a favorite. So that contributes some layers here, and then on top of that, every run, copy, or add statement you have in your Dockerfile will add a layer. This has changed recently because earlier every command used to, like every instruction in the Dockerfile used to create an image, but this has changed recently. Now it's just a temporary thing, and the actual images in the final product are just the ones created by those three instructions. So keep that in mind. And every container you run from this image, you can run 500 containers from this single image, and they will all have these layers which come from the image, and then on top of that they'll have their own thin read-write layer, it's called, because this is the layers below that. The container can't change; they're already there. All the changes that are going to happen are happening in the thin read-write layer which the container has for itself. And this is not shared. An example, probably a bad example, but easiest one I could think of is if you have a service which is running inside a container and it's writing logs to itself inside the container. This is something that goes in the container layer. This is not something which we are talking about in this talk particularly. That's also a bad example, so don't do that. Now the first thing is, as I said, I will be talking about reducing the absolute size of the image. And this is the obvious thing which you should first do, is choose the correct base image. Now this is not something you can always do, but if you can, just see the difference. So instead of starting from Ubuntu and installing Python in it, you will start directly from a Python Alpine image. Alpine is another popular base image which is used quite extensively in Docker nowadays. So that results in a total final image of 88.5 MB. This is already quite small compared to what I have earlier. This is functionality was in no way different. It just doesn't have some additional components which I had in my previous image, but which I didn't need. So this reduces it. Let's say you have corporations have compliances, and this is a problem if you want to use Alpine. So they've completely tested some operating systems and they've whitelisted and said you have to use these base images. We don't permit using the other one. Where at a startup, perhaps this is not a problem. You can use whatever you want. But some organizations have compliances, so you can still save a lot if you just remove the stuff that you don't need. So the second one you see, the Python Slim. It's 150 MB and it's Debian. Not like it reduced from to a container specific file. It's Debian, which is quite popular. So you still saved about 300 MB over there. So base image is the easiest and the most obvious way. But this is also probably the most boring. It's something which most people know. Next part is quite interesting. So as I said, every run, copy and add statement adds a layer to your file or adds a layer to your image. And this is a bit difficult to understand because the layers stack on top of each other. It's not like if you have something in the layer below, it's not going to show up in the layer above. It is. This is not how it works. So look at this file first. I don't know if you can read, but what I'm doing here is I'm adding a package, and then I'm removing something in the next jump statement. Similarly here, so this example, what I'm trying to give here is I'm downloading a very big access log for Apache, about 500 MB, or probably even bigger. I am doing some operations on it, and ultimately what I want is to have a unique IPs which access my service. This is publicly available access log, and I've run this on this. So what I've done is I've first downloaded the access log, then I've run my operations on it, created a new file, and then removed the access log. So the file that I've created is only 6 MB, but my Docker image is still 551 MB. Why is that? Because the run statement in which I downloaded the file stays there. And removing the file in the last statement, that has no impact because the layer is already there. Whenever I download the image, it will still come. Is there a way to do this better? I've said that the headline is to reduce the number of layers. Can be a bit misleading, but in this case, it's not something you normally do with a container. Which makes the example, make this problem very understandable. So instead of doing this, which was 551 MB, I do this instead. So you can count the run statement in the first one: 1, 2, 3, 4, 5. Now I have 1 and 2 only. This will result in less number of layers. That's fine, that's good. But why is the final image only 6.54 MB? Because the main bulk of that image was coming from this access log which I had just downloaded. Now I'm not keeping it. I have downloaded it, I've processed it, I've created my new one, and I'm also going to remove it after that. So I'm not even removing it, so I'll just pipe it. Once this layer ends, there is no record of this file anymore. So this kind of thing can be done to reduce layers, but the layers should be reduced for a reason. So if they don't fit logically, so all the operations I was doing were on a single file. I reduced them, and in the ultimate Docker image, I don't have it. I just wanted the unique IP, and that's all I have. So this, so far I've talked about reducing the absolute size. I said there's the second part, and probably the more important part, is the incremental builds. The builds you have to push out via continuous integration or continuous deployment system. This is where this kind of thing can help you a lot, because even if you have to use this U base image, that's fine. But as long as my code change doesn't take a layer which is 500 MB, it's just 5 MB, that's acceptable to me. If I have to just put 500 MB one, that's okay. So yeah, I think I will just share in the first line. So probably one more there. You have to share everything you can when it comes to Docker images. This is the whole point of using layers. So if you are using layers, you can reuse them. This is the kind of points I will make now, and I have 3 sort of scenarios in which I'll show how to do this. Hopefully they're clear. I'm trying to keep this language agnostic, so all the principles I show here can be applied to most languages, but some of them apply to specific languages, so I try to highlight that. So this one, again, it's a Python application. But this example also lends itself very well to Node.js. I guess you have a set of requirements, you have a package which installs all the modules, right? So it's a very simple application. What I'm doing over here is I'm copying over my application into an app folder in the container, and I'm doing a pip install of all the requirements. And then I'm running the application. So imagine this is again a hello world application. I change hello to hi. What happens? So my first layer, which is because of the copy statement, that gets invalidated because it's now copying a new file. And once that happens, every layer below that also gets invalidated. And so you can see over there the green line which I've drawn, all of those layers will have to be redone. I cannot use anything from cache, because if I change something in my first statement, everything that came after it is going to be redone. This is a problem. Do you think we can make this better? Because I just want to change my code, I don't want to change my requirements all the time. Maybe I do someday and that's fine, then this will run again and that's okay. But we can make it better, like this. Just do the requirement stuff before, why not? So copy the requirements first. So now I have more layers. You can see I have more layers. So this is more efficient. Why? It's the same side. I'm doing the install of the requirements first. So this layer is now cached. If I do a copy afterwards and I change some part of my code, this is not going to invalidate the requirements which I've already gathered. So they can stay. So if I change hello world to hi world, this is only going to be split second basically. It's going to compile, or rather it's going to complete instantly. I don't have to do any of the stuff that happens before the statement. This can be used directly from cache, and I just have to copy my app into it. So this is the kind of thing that can help you a lot. So this is not just when building. When you create this new image, so it's just one new layer, everything else is already in your registry. So you don't have to push it either. to gain speed there. When it comes to deployment, suppose you're running a cluster and you have this app deployed on one of the nodes. If that same node is deploying the app again, it will only pull the new layer. It will not pull the base layers which are already there. So Docker is smart that way, and that's why the deploy will also be quite a bit faster. Now I want you to look at this Dockerfile for a while and forget the on-build instructions. Like everywhere I've written on-build, don't care about it right now. The point I'm trying to make here is you can use common base images. Suppose I don't think there's any company out there that writes a single service now. They write a lot of services and most of them are common. They have a lot of common things. For example, I've taken again Python, it can be anything. If it's a Python shop that writes a lot of Flask applications, you can create your custom image with only the stuff that you need, or rather all the stuff that you need in all of your containers. Put that in one base image, push it out, and use it everywhere. It will result in something like this. To create a new base image, so just focus on the diagram there, to create a new base image and push that out. Every service you use, or which requires that kind of Flask infrastructure, use that as a base image, because now this base image will be pulled only once. If this base image is only pulled once, all the service layers are basically just your code. Code is never as big as the base image. So this kind of thing can also help you share a lot. Now I'm going to go back to this slide. I told you to ignore the on-build instructions right now. So far what I've done is I've shared the image. So my deployment is fast, my build is fast, all that kind of thing is good. I was only building the base image once. But imagine you have 50 microservices which almost all have the same structure, same requirement. You have to write this Dockerfile for all of them. What you can do is use on-build instructions and you have to write it just once. I'm going to show you how. So this is a normal method I would use for containerizing a Python application. So I do the requirement stuff first. Why do I do it first? Because I don't want to invalidate my cache. And then I do this, copy my app. But this is on-build in front of it. This is a fairly new addition to Docker. And what this does is, it says when I build this Dockerfile, it will tell the Docker daemon that don't execute this instruction right now, because I'm doing this from a folder which doesn't have any code. I'm going to build this Dockerfile from there, Docker image from there. The difference is when this container, or rather this image, is then used as a base image for any other container, or rather any other image, which you can see over on the right side. So there's just this from statement, and this from statement is using the image which I have built over here. And that from statement is the only Dockerfile you need in all of your applications now. It's common. With just one line, it will execute the same instruction whenever it's built for whatever application. So again, not only are you reusing images here, you're also reusing Dockerfiles. So this makes less code. You can do it in one place. If you want to push out a change, or rather if you have let's say new requirement that all containers should have so and so agent, you can do that in the base file. And all of your other subsequent builds will get us. So again, quite interesting. Right. So this is my personal favorite. So I've talked about Python so far. It's not something you compile. A lot of other languages that you do build compile, right? This is where this kind of method is very useful. What am I talking about here? So I'm talking about what you need to build an image is not what you need to deploy. There's a big difference between the two. For example, I think Java is something people are familiar with, so you don't need the entire Java development kit to run a Java application, right? But you need it to build the Java application, and you need all the requirements. So just keep that in mind. So I've taken the example of Go, which is what I write most of my code in. It is normal, compile it, get a binary, and that's all you need. What I've done over here is again copied my code, done my dependencies, done my tests and environment variables and whatnot. In the end, what you need to focus on is this statement, and I am creating a binary from it. Once I have that binary, everything I did before it is not useful to me because I have the binary already. Why do I need to have all that stuff there? And then I'm just running this binary. So again, the first application I ran for Golang in a Docker container was written like this. So this is natural to people, Just use what you have already. and this was 774 MB for a simple service like hello world equivalent. Again, 774 MB. So what I want to propose here, or this is now an accepted method also. We were doing this in a very dirty way earlier, but ever since I think Docker 17, I don't remember the version, but there is a provision for multi-stage Docker builds now. This helps us a lot in this kind of case. You see, there is a separation between my two files. This is just one Docker file. This is not two Docker files. This is one Docker file, but I've made a deliberate separation between the two of them. What I'm doing first is the exact same thing I was doing earlier. I'm just building a binary. At the end of that run command, I'm going to have a binary. But what's going to happen here is this is something which you're not familiar with. There's a second from statement in the same Docker file. If you do this, you're going to basically say, this is going to be my final image. Everything I've done before is just for building a binary. So, first one is the builder. The second one is my final image, where I've done a copy from builder. So I can use artifacts I built over here in my final image, but I can completely ignore that. So my final image is not going to contain any of the Golang development toolkit. Let's make it 16 MB from 774 MB. Now this can go even further. So the 10 MB which I was talking about can go even further. The actual binary is only 7 MB, while it's 16 MB. Because you can see I'm using here Alpine. You can, instead of Alpine, use Scratch. Scratch is something which is very good for binaries that you can run directly in a Linux system. You don't need to care about anything else. So Scratch is basically nothing. So no Ubuntu, no Alpine, nothing. There's no package management either. The reason why I haven't used it because I want to use SSL. So CA certificate, I want to do some sort of SSL checking in this. So that's why I went with Alpine. Carried 10 MB, which is acceptable. Compared to 774 MB, I happily had 10 more MB just to do SSL. But the best part is I only have what I need in my image. That's the point I'm trying to make. Okay. Right? I talk about security, right? And this is not clear at all. But what I did was run an image scan, which scans for vulnerability in the image. This is a public image on Docker. This is the first one. This one. I ran a scan on it, got about 500 vulnerabilities, about 120 of them were highly critical, not critical but high vulnerability, and they're obviously bad because all I have is a single binary and I want to do SSL. That's the only thing, like SSL checking, that's the only thing I want to do, and I have so many things over here I can't read the names, but libcurl, bazaar, I don't need all of that. No? If I run the second one, the one with the slim image, where I move everything, all it has is 2, and that's also in libSSL which I just put. So this can be upgraded. So we went down from 500 security vulnerabilities to 2, just by having a more efficient Dockerfile. So this is the kind of thing I was trying. This is not completely. I'm not trying to completely educate you on this kind of thing. This is just to put the idea in your mind that write your Dockerfiles carefully, especially if you want to run them in production. Because they can have a big impact. And yeah, since I think I'm out of time, so yeah, I just do this very quickly. There's some random tips which didn't fit in any slide. So you can use Docker ignore, like git ignore. It's very simple, right? If you're building binary, consider Scratch. Talk about that. Prune and purge your system. This is not really part of this talk, but good practice anyway. And compliance is also still something I've talked about. So this talk was inspired a lot by Abby Fuller's talk on Docker 70, so do watch it. If you think what I've talked about is interesting, definitely watch it. And everything I've said is in the official Docker docs, so you can just read them. This is just better information. Thank you.